All right. We have been given a question that says in the diagram, A with coordinates 2 and 1, C with coordinates -6 and 3, and B are the vertices of triangle ABC. D is the midpoint. It has the coordinates -5 and 2, and it is the midpoint of BC. Straight line BC makes an angle of theta with the x-axis, and we can see that on the diagram as well. All right, so let's jump into the questions. I think probably the first 3 questions, you guys are probably fine to do those on your own. Perhaps when it gets to question 3.4, we may need to have a little bit of a discussion. So go ahead and answer questions 3.1, 3.2, 3.3. I'll go and grab, sorry, I should have put this up here as well. Let me just stick this here. And then you guys have got the formulae right in front of you as well. All right, and then you can share your answers with Yolanda and I. You can do that by direct messaging us and not messaging everybody, because then at least people who haven't finished aren't discouraged. Okay, so I'd like you to do the first 3 questions on your own, please. Yeah, and then when you're done, you can DM Yolanda and I. Yolanda, I'm just going to grab a pen. I'll be right back.
Okay. And so we're doing 1 up to 3, guys. 1.1, 1.2, 1.3.
Okay, so just in case there's anybody that's just joined us now, we're just having a look at this question. You guys are doing 3.1, 3.2, and 3.3 on your own. I'm going to start talking to you about question 3.4 when you are ready. And I've just encouraged you to send me through your answers by direct message. You can either send them to me or to Yolanda. Okay, so Mamelo, I got a slightly different answer to you. My root was the same, but the number in front is different. Gugu, I got the same answer as you. Mamelo, I got the same answer for 3.2. Gugu, same answer. Mamelo, same answer, just careful there with your rounding. Don't round to 70. We'll look at the calculator now. Yes, Awami, perfect, good. Okay, Lebogang, we got a different answer for 3.1, but the same for 3.2 and 3.3. Yes, Ayanda. Yes, Gugu. All right. So just giving you guys a little bit of feedback there. I'm just going to work quickly on question 3.1 down here at the bottom. That's it. There we go. That's correct, Mamelo. Well done. Or maybe what I'll do is I'll just stick it in up here. So calculating the length of AC, you would have had 2 plus 6 squared plus 1 plus 3 squared, and that would have given you 4 root 5. I hope that's visible to everybody. So a mark for subbing in and a mark for the answer. It would be out of 2. That's it, Rafense. Well done. Lesejo, that's right. Good. And then calculating the... That's all right, Randy. Welcome. We're just busy going through 3.1, 3.2, and 3.3. Everybody has just tried these questions on their own, and we're just sharing some answers. The gradient of DC. So remember, I told you before, put in the name of the line that you're calculating the gradient or the distance of. It just makes your life easier if you have to use that information later on. And it also tells whoever's marking your work that you are doing the right thing. Okay, so at the top here, I got 2 plus 3, and at the bottom, I got minus 5 plus 6. That gives me a gradient of 5. So again, a mark for subbing in, a mark for your answer. And then in 3.3, the dot should be there, 3.3, the gradient of the line is positive. So if tan theta is equal to 5, it means that theta has to be an acute angle. So I also got 78,69 degrees, as so many of you have sent through to me. Okay, and again, a mark for subbing into tan theta equals gradient, and a mark on your answer. Oh, okay, Lebogang, there we go. So just be careful here. It said simplified third form. Okay, so 4 root 5 would be simplified third form. Okay. Yes, and then just be careful. All your answers should be rounded off to 2 decimal places. It doesn't say that here, but oh, sorry, it says rounded to 1 decimal digit. Sorry, and there I'm telling you to read, and then I didn't read it. That's quite unusual. It's not generally like that. So what I should do here is it would be 78,7 degrees. Okay, and then it would be to 1 decimal digit. Generally, they tell us to round to 2 decimal places, and I think that's what they would expect us to do in our exams as well. Sure, Pumzile. So in order to calculate the size of an angle of inclination, you're going to use this formula over here. So the letter M here represents the gradient of the line whose angle of inclination you're trying to calculate. So here is your line DC over here, and there is theta, your angle of inclination. So when we want to calculate the size of an angle from the gradient, we have to press Shift Tan on our calculator. So you would go Shift Tan, and then you'd put in 5, and then it would give you the size of that angle theta, okay, which is 78,7 in this case. All right. Luzo, you didn't miss anything. We're just going through the answers for the first 3 questions. Okay, so remember, guys, when you sub into a formula, you've got to show that you subbed into the formula. All right. Don't write the formula down and then do the calculation on the calculator and write down the answer only. You've got to show that you subbed in, and then you're going to pick up your calculators. All right. So I think it's Lesejo. No, hang on. Let me just have a look here. Yes, Lesejo, you've suggested an answer for the value of K, which is fine. I just want to talk a little bit about this question before I give you guys a chance to answer it. Can any one of you tell me, what does the word collinear mean? So when they talk about points that are collinear, what does that mean for us? There we go. There are points on the same straight line. So if they are on the same straight line, what is the same for them? If they lie on the same straight line, what is the same? Their gradient. Good. Well done. Well done, everybody. Brilliant. Okay, so I'm going to let you work out the value of K now that you have demonstrated you understand what the word collinear means. Work out the value of K. Okay, so I don't know if I've made a mistake. I'm getting a different answer to the one that you sent me, Lesejo. I got a different answer. I hope I've done this correct. I just want to see what you guys are getting. Okay, now I'm getting the same answer, but I didn't want to use D. That's funny. Okay, so Lebogang, I got the same answer as you. Gugu, I see you've got the same answer, but your sign is different. Any other answers coming through before we talk about how we would do this? All right, so if the coordinates at point E are -3 and K, and DC and E are collinear points, then what it means is that E has to lie somewhere on this line as well. All right, so maybe somewhere up here. So E has the points, that would make sense that it would have to be negative then, wouldn't it? -3 and K. So we know that the X is negative, but we don't know whether it's in the third quadrant, or it could be somewhere up here as well. E could also be there. We actually don't know its position. So we know that the X is negative, the K could be positive, or it could be negative. So what we would use here is, all right, good. So let's have a look, and then you guys can scrutinize what I have done. We're going to use the concept of gradient because CDE or EDC is a straight line. Okay, so that means that the gradient of this line is equal to 5. We've already calculated that previously when we calculated the gradient of DC. So now we need our change in Y at the top. So let's say I decide I want to use the coordinates at C. It shouldn't matter whether I use the coordinates at C or D. I should get the same answer. Let's say I want to use the coordinates at C. So my Y coordinate at E is K. My Y coordinate at C is -3. So I'm subbing into gradient formula. So this will become +3. Then I've got to go back here and I've got to take the X at E, which is -3, and then take the X at C, which is -6. So this will become +6, like so. And then I have subbed into gradient formula. Sorry, I was naughty. I should have put here that I'm doing question 3.4. So now what I can do is simplify my denominator. -3 + 6 will give me +3. And now I'm going to cross multiply. Okay, so remember this 5 is actually 5/1, and then I can cross multiply in order to solve for K. So I'm going to say 3 times 5 is 15, and it is equal to K + 3. And then I want to transpose that 3 over to the other side. So I'm going to get an answer of 12 for the value of K. All right. Okay, so that's that one. There would be a mark for summing in, simplifying, and then getting our answer over there. The last thing that we need to do is calculate the coordinates at B. And that is out of 4 marks. All right, so any ideas on how we would do that? What formula would we use to calculate the coordinates at B? What do you guys think? Okay, so Ayanda's giving me an answer. What formula did you use, Ayanda? Midpoint formula. Good, well done. Okay, so they told us here that D is the midpoint of BC. All right, so we're going to work backwards using our midpoint formula to calculate the coordinates at B. All right, so if we want to calculate the X coordinate first, we would say the X coordinate at B plus the X coordinate at the end over here, that's -6, all over 2 would give us the X coordinate at the midpoint, which would be -5. So I'm just going to scooch down just a little bit. Now I'm going to cross multiply. So I've got the X coordinate at B -6 is equal to -10. And then I'm going to take that -6 over to the other side by adding 6 to both sides. So that would leave me with -4. So it's falling in line with what you said, Ayanda. And that makes sense because B is clearly a point in the second quadrant where we would expect X to be negative. We'll do the same thing with Y. So we'll say the Y coordinate at B plus the Y coordinate at the other end, which is -3, all over 2 is equal to the Y coordinate at the midpoint, which is 2. So again, if I cross multiply, I get the y at b minus 3 is equal to 4. And then I'm going to add 3 to both sides. So that would be equal to 7. So yes, I agree with you, Ayanda. The coordinates at b would be -4 and 7, just like that. Okay. Is everybody happy with that? Are our brains warmed up? Are we feeling good? So sub in, answer, sub in, answer. And then remember, if they ask us for coordinates, give them coordinates. Okay. All right. Lovely. Good. All good. All right. Brilliant. Okay. So let's go on and have a look at a circle now. So in this particular case, I'm just going to move this down just a little bit. Put that over there. There's our formulae. Okay, so AC is the diameter of the circle with center B. The circle passes through the points A with coordinates -1 and 8, and C with coordinates 5 and 0, and D lies on the x-axis, and we can see from the coordinates that C has to lie on the x-axis as well. The first thing that they want us to do is show that, let's just make this a tad bigger, show that the equation of the circle is x minus 2 squared plus y minus 4 squared is equal to 25. All right, so what are the rules when it comes to any question that says show that? What are we not allowed to do? Exactly. We're not allowed to use the given information. We're not allowed to use values from the answer. Absolutely. Because if we do that, we are not showing or proving, we are verifying. And exactly, Kalipa, we're not allowed to use the numbers that have been given. All right. So we've got to do it another way. Can anybody tell me what they think I should do here? What do we think is important for us to establish in order to answer this question? What are we looking for? There we go. All right. Can you calculate the coordinates of the center first? Yes, you can. Absolutely. And we need the coordinates at the center because we know that that's got to go into the equation of our circle. All right. So the A and the B in the equation of our circle, when we change their signs, those are the coordinates at the center. So we need to do that. How are we going to find? All right, so we don't use gradient to find R. Remember, R of Fencer is the length of the radius. So if we want to calculate the length of a line when it comes to the radius, we're going to have to use distance formula. All right, but first things first, how are we going to calculate the coordinates at B? All right, brilliant. Okay, you guys go ahead and do that. Calculate the coordinates of B and then tell me what you get. There we go. Me too. Thank you, Tirfatso. Thank you, Cheslin. Yes, Akila. Perfect. Yes, Lesejo. Lovely. Well done. Okay, so you've got the coordinates at the center of the circle using midpoint formula. Obviously, the center of the circle is going to be the midpoint of the diameter. Brilliant. Okay, so as far as that was concerned, we said -1 plus 5 over 2. And over here, we said 8 plus 0 over 2. And that's how we have the coordinates at the center be the coordinates are 2 and 4. And again, that makes sense to us because we can see that it's a point in the first quadrant. So it makes sense that they're both positive. Lovely. That's it, Amahle. And now, how are we going to calculate the length of the radius? How are we going to calculate the length of the radius? What should we do here? Can anybody tell me what I should do? Okay, that's it. Good. So use the distance formula. Brilliant. Good. Use the distance formula. And people are saying different things. And so far, everybody is saying something that's correct. So either you can find the distance from A to B, or you can find the distance from B to C. It doesn't matter. Or if you wanted, you could find the distance from A to C and halve it as well. Any one of those three would be absolutely fine. So we're going to sub in. Let's use B and C in this case. So again, we're subbing into into distance formula. So that would give us 2 minus 5 squared plus 4 minus 0 squared. And what are we getting as the distance of BC, or the length of the radius? What does that give us? Good. All right. And we're happy about that. That's what we were expecting as an answer, isn't it? Because when we have a look at the question, we can see over here that this is 25. So remember, what is on the right-hand side here? That represents r squared. Okay, very nice. Well done. So what I could also do here is I could say that this is the radius and it is equal to 5. So therefore, r squared would be equal to 25. All right, so that means that the equation of the circle has to be x minus 2 squared plus y minus 4 squared. Whoopsie, not that way, the other way, equals 25. Cool. So remember, it's the radius is squared, Mamelo. Okay, when we're subbing it into our formula, the length of the diameter would be 10 though. Okay, but on this right-hand side of our equation, that is r squared. It's not the length of the diameter. Okay, so midpoint, getting that answer, then subbing in and calculating the length of the radius and getting that it is equal to 5. We obviously wouldn't get a mark for the 25 because that's given to us. Okay, all right, now they want us to calculate the coordinates at D. How would we do that? How would we calculate the coordinates at D? Any ideas? Remember, it told us in the beginning that D lies on the x-axis. So I'm giving you a hint here. Exactly, Pumzile. It is an x-intercept. So we would have to let y be equal to 0. Okay, I'm going to let you guys do that. You've got the equation of the circle here in front of you. So try it, and then you can DM Yolanda and I your answers. Okay, so Cheslin's offering their answer. The rest of you keep going. Okay, Mamelo, there's an answer from you. Thank you, Gugu. Let's see what you guys are saying. Okay, so a lot of you all getting the same answer. Excellent, lovely, well done. All right, so just formalizing that very quickly. You guys have already done this. I'll just show you where your marks would be allocated. So of course, we've got x minus 2 squared plus, and then we said that at dx, y is equal to 0 because it's an x-intercept. So this would be 0 minus 4 squared is equal to 25. So that would have given us x squared minus 4x plus 4 plus 16 minus 25. Getting into standard form, we would have had x squared minus 4x minus 5 equals 0. And then you could have used the quadratic formula if factorizing is difficult. Otherwise, you would have factorized, and here you would have said x minus 5, x plus 1, and therefore two solutions for x. X is equal to 5. We're expecting that because we see the other x-intercept is c at 5 and 0, or x would be equal to -1. So at D, x is equal to -1. So therefore the coordinates at D would be -1 and 0. Well done. Oopsie, what have I done here? Sorry. Ach, silly pen. Sorry, guys. Let me just... Sometimes there's this button on the side of the pen and then you press it accidentally when you're writing and then it makes these silly irritating scribbles everywhere. Okay, so a mark for making y equal to 0. There's always a mark on our factors or using the quadratic formula. There has to be a mark on the answer. So probably the other mark would be on getting it into standard form, like so. Okay, well done. That was really good. And now the last question in question 4. Here they've asked us to determine the equation of the tangent to the circle at A for 5 marks. Determine the equation of the tangent to the circle at A for 5 marks. What do we need to do here? Can anybody explain this or tell us what we need to do before we get started? What are we looking for when we want the equation of a tangent to a circle? Correct, Cheslin. So we want the gradient and a common point to sub into y equals mx plus c. Gugu's correct. Our starting point is finding the gradient of AC. Good. We know that we've got our point A that we can use. What's the other important thing that no one has mentioned at this point? There's something else. That's it. Okay, so the gradient of the tangent times the gradient of line AB or AC has to be equal to -1. All right, and the reason for that is because the radius is perpendicular to the tangent. Okay, yes, and it's very important that we state that as well. Okay, so let's begin. I'm going to slip this question in over here, 4.3. And let's begin by determining the gradient of line AB. So we'd say 8 minus 4 over minus 1 minus 2. So the gradient of line AB is 4 or negative 4 over 3. Are you guys getting the same answer? It doesn't matter, Ayanda. You can do AB or AC. It doesn't matter. It's probably safer to do C because that's given information, but we're confident from the work that we've already done that the coordinates at B are 2 and 4. Okay, so in the same way as this question up here, where they spoke about E, D, and C being collinear, A, B, and C are also collinear points. They lie along the same straight line because it's a diameter. So whether you want to work out the gradient between A and B or B and C or A and C, it's not going to make any difference. Okay, lovely. All right, and now we need to say that the gradient of AB times the gradient of the tangent is going to be equal to -1. And we need to provide a reason for that. That is because the tangent is perpendicular to the radius, or the radius is perpendicular to the tangent. Okay, so that means that the gradient of our tangent is going to be the reciprocal, and then we have to change the sign. So it would have to be 3 over 4, positive 3 over 4. Good, Zechofatso. And now we can sub in our point that we've got. We're going to use A because it's a tangent to the circle at A. It has the coordinates -1 and 8. And now I'm just going to move this out the way. That's the question we're going to look at next. I'll just move that down a little bit. And now we're going to sub into y equals mx plus c, which is what you guys were saying about gradient and a point. Okay, so the y coordinate is 8 when the gradient is 3 over 4. The x coordinate is equal to -1, and that allows us to work out the size of c. So how big is c? What are you guys getting for c? I also got 35 over 4. Okay, just careful there, Chesna. I don't know if that was just a typo or whatever. I'm also getting 35 over 4. Maybe you subtracted instead of added. Okay, so y equals 3 over 4. X, don't leave the x out. Often we're in such a hurry when we're answering these questions, we leave things out. So don't leave out that x over there. It's okay, Chesna, no stress at all. Okay, and that was out of 5 marks. All right, so our marks here are going to be for calculating the gradient of AB or AC, using or obtaining the correct gradient, subbing in our point, 1, 2, 3, mark there, maybe a mark for subbing in over here, 1, 2, 3, 4, 5, yeah, like so. That's it, well done, good Mamelo, good Zechofatso, and everybody else that sent through answers, brilliant. Okay, so that's gone really well, nice. Okay, so now we've got about 15 minutes left. What I'd like us to do, are there any questions, sorry, before I move on? Or are we all good? Mamelo's happy, Kalipa's fine, Gugu's fine. Okay, all right, good. So you know you can interrupt me, raise your hand, and ask to speak if you've got any questions or comments on what we've done. Okay, so now that our brains are properly fired up, let's have a look at this yummy, delicious problem-solving question. Okay, so this is actually something that I had wanted to do in one of our previous lessons, but I just never quite got around to it. So I thought today would be a good opportunity to be able to do this question with you guys. All right, so it's out of 6. And it asks us to determine whether or not the circles having equations x plus 2 squared plus y minus 4 squared equals 25 and x minus 5 squared plus y plus 1 squared equals 9 will intersect. So show all calculations. So they're asking us a question about whether the circles intersect or not. So do the circles cut each other? If we were to sketch them on the Cartesian plane, would they cross over one another? No, we don't do a simultaneous solution, Amahle. No simultaneous solution here. But I'm glad you're thinking and you're asking questions. Find the radius and then the distance between the radii. Pumzile, you're getting closer. You're getting closer. That's good. All right. So the idea is this, okay? If two circles do not intersect one another. So let's say I've got a circle over here, and I know I'm drawing these circles very badly, okay? And I have a center over here, I'll call that C, and I'll have a center over here, and I call that D. Now, here is the length of this radius, and here is the length of this radius. So what I would find in a situation where circles do not intersect is that the distance between the centers is greater than the sum of the radii. That's it, Zechofat. So you've got to compare the sum of the radii to the distance between the centers. Okay, let me write that here for you. So you are comparing the sum of the radii to the distance between the centers. Does that make sense to everybody that we would do it like that? Okay. Or, so the other situation is that you could find is that the two circles are tangents to one another. In which case, so there's our centers again. So here's this radius, there's that radius. So now the distance between the centers is equal to the sum of the radii. Then the circles are going to be tangents to each other. And the circles will intersect one another more than once. So again, if that's the center of this circle, that's the center of that circle. There's our radius and our radius. So now the distance between C and T is smaller than the sum of the radii. Okay, so that's what yes, there we go. So that's what we are trying to do. But now we cannot make an assumption about the left-hand side and the right-hand side. So we're going to work out the distance between the centers, and then we're going to work out the sum of the radii, and then we're going to compare them. Okay, so first of all, let's work out the distance between the centers. So let's call this circle center C, and we'll call that circle center T. So what are the coordinates at the center of C? Circle C. What are the coordinates at its center? It would be -2 and +4. Okay, the other circle with center T, its coordinates are 5 and -1. So the first thing that we're going to do is we're going to calculate the distance between the centers using distance formula. So we would say minus 2 minus 5 plus 4 plus 1. And that's it. Good. Well done, everybody. And that would give us a distance of 8. What are you guys getting? That's it. Me too. I'm getting root 74. And just to make it easier for me to compare it, I'm going to round this off so that I can see actually what it is as a decimal. So this gives me 8,60 units is the distance between the centers. Now, in a separate calculation, good, root 74, beautiful. Now, in a separate calculation, I'm going to do the sum of the radii. So I've used a capital R for the one radius and a small r for the other radius just to differentiate between the two of them. Okay, so if I go back up and I look at my equations, I can see that this circle over here, r squared is equal to 25. So that means that the radius is 5. In the other circle, I can see that r squared is equal to 9. So that means that its radius is equal to 3. That's it. Well done. So the one radius is 5. The other radius is 3. And that gives me a sum of the radii of 8. So now I'm going to make my comparison. The distance between the centers is 8.6 units. The sum of the radii is 8. So do the circles intersect? Are they tangents? Do they intersect more than once, or do they not touch each other at all? What would you say under these circumstances? They don't. They don't intersect. Okay, so it's like the first scenario that I was describing to you. Okay, so the distance between the centers is bigger than the sum of the radii because 8,6 is bigger than 8. Okay, so they don't intersect. All right, they do not touch each other. All right, so that's what we would need to say now. Okay, so 8,6 is greater than 8. Oh, greater than 2. What am I writing here? So 8,6 is greater than 8. So that means that the distance between the centers is greater than the sum of the radii. Therefore, the circles do not intersect. Okay, it's scenario 1. It certainly is. Okay, so there would have to be a mark on my reason and my conclusion. I would have to write those things. There would have to be a mark for subbing in and getting the correct distance between the centers. There would have to be a mark for calculating the radii and the sum of the radii. How much was it out of 6? 1, 2, 3, 4, 5, 6. Okay, like so. All right, are there any questions about this? No, we're all good. Okay. All right, brilliant. Okay, so what I'm going to do this evening, because it's quiz night, is I'm going to let you guys go just a couple of minutes early so that you can do your quiz. We do. So when they ask you about whether circles intersect or not, that's exactly what you're doing. You're comparing the sum of the radii to the distance between the centers. Okay. So any homework? Good. Do you want some homework? Yes, please. Okay. So what I'm going to do, Gugu, is I'm going to, okay, this question is a little bit more difficult. Okay. But here, and then I can post the answers for this. Hold on. Let me just try and scooch over a bit. Just make this a bit smaller, Gugu. Hold on. Anybody else that's interested in homework is obviously also welcome to try this question. There we go. Oh, hold on. I tell you what, Gugu, let me just make this a little bit smaller as well. There, because I want you to be able to see the mark allocations. Okay. So Gugu, screenshot that, and anybody else who's interested. And then the next time we go through these sorts of questions, I can share these answers with you. Okay. All right. Okay, so Kalipa, I'll just quickly go back. Anybody else, if you want to go, you're more than welcome. You don't have to stay. So, Tsegofatso, before I just get started with this, it's a pleasure. If the distance is the same as the radius, it means that they are tangents to each other. So it's this middle scenario over here. Okay, bye, Luzu. All right, so Kalipa, in order to understand whether the circles intersect one another, you are comparing the distance between the centers with the sum of the radii. Okay, so in other words, if you have a look at this first scenario over here, these circles don't intersect one another because the distance between the centers indicated by this dotted line is going to be greater than the radius of the smaller circle plus the radius of the bigger circle. So you're always going to be doing that. You're always going to be comparing the distance between the centers with the sum of the radii. All right, and then these are things that you need to learn. So when circles do not intersect each other, the distance between the centers is greater than the sum of the radii. So what you needed to do is work out the distance between the centers, work out the sum of the radii, and then make a comparison between the two. So because the distance was 8.6 and this was 8, we would have said it falls under this scenario where the distance between the centers is greater than the sum of the radii, and that's why the circles are not intersecting each other. Okay.